Hey you all, so this is kind of day 2 of this assignment. Okay, this is the same assignment as yesterday, solving systems by any method, but today I want you to go ahead and do the back page. Now, something that we do need to talk about are things like number 11, number 17, 18, 19, and 20. Now, why I put number 11 up there is what I don't know, but these are the kind of problems we really need to be paying attention to as well. So what I want you to think about, and I know I'm not in front of the camera now, so it's probably going to be kind of more boring, but I'm sorry. So what I need you to be thinking about is what is different between number 11 and 17, 18, 19, 20, and things like on the front and the ones that I haven't circled. So think about that for like just a second. Okay, so kind of what I wanted you to realize is that things like number 11 and then these down here, it's not very clear on what method that we should use, right? Because this definitely does not look like an elimination problem because the variables aren't lined up. Remember, we talked about that kind of stuff yesterday. If the variables aren't lined up, don't use elimination, okay? It makes no sense. So what we're going to do here, and I'm sorry, my camera is kind of being blurry. What we're going to do here is things that look like this. So it's clearly not an elimination problem. We are going to force things like number 11 and the rest of these to be substitution problems. That's ultimately what we're going to do here. So let me go ahead and open my pen here. So what I want you to do, I'm going to write notes over here. You can write them on your own piece of paper or you can write them over here as well. So we are going to force these problems to be substitution. Now, remember when we do substitution, force these problems to do substitution. When we do substitution, remember that we have to have y equals something. So y equals all this stuff, or we have to have x equals all this stuff. So let's just look at number 11 really quickly. I want you to think about these two equations and how we could force this to be substitution by having y equals something or x equals something. So just think about that to yourself for a couple of seconds, and I am going to give you time. Okay, so let's go ahead and talk about this together. We are usually on substitution, not always, but usually we have y equals something, usually. So that's just what we're comfortable with. So I want to go ahead and teach it that way. We're going to look at number 11 and we're going to look at this top equation. We could easily force this to be y equals something. I'm just going to rewrite this equation. We're going to have y minus 10 equals 2x. Okay, so if we were to force this to be y equals something, we would clearly have to move this 10 over here, all right? We're not going to have y equals a number. We're going to have y equals an equation. So what would you do to this 10 to get it to the other side? So think about that. Okay, so this is just like solving a literal equation, right? The 10's being subtracted, so we add 10 to both sides. Negative 10 and positive 10 eliminate, so we have y equals 2x plus 10. And this is your new equation of this. So all I did was just force this equation to be y equals something. So this equation is now irrelevant up here. That equation's gone, so we scratch it out. So we are going to rewrite the two equations that we have. We're going to have 2y equals x plus 5. That's just me rewriting this bottom equation. And then we're going to have y equals 2x plus 10. Okay, these are my new systems of equations. So I have forced this to look like a substitution problem. All right, now we're going to circle the bottom equation, remember? We always want to circle the one with y equals something or x equals something. Now, this top equation does look a little bit different, but just breathe and draw your arrow where you're supposed to. So remember, this is going to go in for y. So we're going to put that whole equation in right there. All right, and you're probably like, well, what does that look like? Now let me show you. So we're going to have 2, then we immediately have y. I'm going to try to do this in a different color here. We immediately have y, so go ahead and put that whole equation in. So just like that. All right, 2 and then 2x plus 10 equals x plus 5. All right, then we're going to distribute. So when you distribute, make sure you draw your arrows if you have to. So then you would have 4x plus 20 equals x plus 5. Remember that there's a 1 in front of here, right? So now we don't have any like terms to combine. So remember, we move that variable. So we are going to subtract 1x from both sides. All right, then these cancel. This is going to be 3x plus 20 equals 5. And then that's just a simple 2-step equation. You should get x equals -5. That's just a simple 2-step equation. Okay, x equals -5. Now remember, you're going to substitute -5 in for your circled equation. So we would have y equals 2, put in that y. I'm sorry, that x. Y equals 2 times -5 plus 10. And then we should get y equals 0. Star that number. Then we should all know that we're going to put this in an ordered pair. So your answer would be -5, 0. Circle, check mark. So here's the thing that I do want to say. This is pretty much, I'm sorry, my camera's going blurry again. Here we go. This is pretty much a very simple substitution problem, but the only additional step that we have to do is we have to force one of these equations to look like a substitution problem. So for example, on number 17, you would do the same thing we did in number 11. You would take this top equation and force this to say y equals something. So you're going to have to do something to this -12 to get it over and find your new equation and scratch this top equation out. Okay, and then number 20. Number 20, I'm going to put up a written example of, so no instruction on number 20, but I am going to put up a written example of this. And I want you to think about these two, because something like these two will be on your test. All right, so we really need to be thinking about things like this as well. So this is kind of a little bit difficult, but if you all have any questions, just let me know, okay? This back page is all due by 11:59 tonight. All right, so here's the thing. That means that this whole page should be completely done by tonight. All right, remember that you have to do the completed work, and then you also have to tell me what method you used for this and explain why. So here is the example that I'm going to post as a picture, but I do have all of like every single part of the assignment in this example. So just to let you all know that, just for comfort. So let me know if you have any questions, okay? I know this is confusing, but it'll be okay. And just reach out to me through email or Remind or on Google Classroom.